Yeah, hello. Good day. This is a video I'm doing on the project, and so I would like you to follow along as I go through with you. Um, we are supposed to download. First of all, we have to install our SQL, and I think the installation everybody has gone through it. Even if you haven't, there was a video on that. Yeah, I think yesterday they put it in a group, so you have to go through that and then install your SQL on the machine. Some were even asking how it will be installed on Linux and all that. But please, I would I would advise that we should stick to Windows machines for the because of this course. You shouldn't go and do or go and then use another OS which will give us problems at the end of the day. You may be able to install it, but later maybe there will be some commands or something that will not work. I'm not saying that it will not work, but if you face any problem, nobody is using Linux for you to get help. So if all of us are using Windows, or most of us are using Windows, if you face any problem, we can help ourselves. uh So I think after installing, this is what we are going to download. We come to our portal and then on the model one. Under model one, we have integrated project Maji Ndogo. The zip file. When you click on it, it will download the zip file. I have downloaded it already. And so this is my zip file. I think after downloading it, I saw it as additional download. So your zip file, you have to extract. So you have to right click and then extract all like this so that it will look like a normal folder like what I have here. We have, so we have I have the zipped one, that is a compressed one, and then the normal folder. So I open this one, you see that we have the MD water services, and then there's dictionary here. When you open this is what you see. Is telling you or is explaining the tables, how they look like, and then their data type. So that is what is there. This thing is also inside the data. So let's forget about that one and then go to the project straight. So this is where you find the project. That is model 5. So here is it. I don't have internet. I have downloaded the PDF. So let me open it. Okay. So this is the project, and it's like a chat, and you read and then you what use it or you follow accordingly. So this one is what is saying, dear team, congratulations on successful completion of our extensive survey. Your dedication and hard work have resulted in an invaluable asset, a database of 60,000 records. So note this, there's a database of what? 60,000 records, meticulously collected by our devoted team of engineers, field workers. Let me highlight that. So let me highlight the 60,000 records here. I'll revisit it in the course of the tutorial. So meticulously collected by our beloved, our devoted team of engineers, field workers, scientists, and analysts. Now the next crucial phase of our mission begins. We need to make sense of this immense data trove and extract meaningful insight. We must breathe life into these records and listen to the story they are telling us. I urge you to load this database and thoroughly acquaint yourselves with it. Dive deep, explore its structure, understand the variable and the connections between them. Each record is a chapter of our story. Each query you run is a thread weaving that story together. This is this is a process of discovery to uncover the patterns and nuances in our data. It's a chance to ask the right questions, to identify the present problems, and to set the course for our data driven solutions. As you proceed, always remember that every bit of information is a piece of the bigger puzzle. Every insight, no matter how small, brings us one step closer to solving our water crisis. Together, we have embarked on this journey to bring about change. Let's continue to march ahead with the same determination and resolve. I believe in our collective potential. Together, we will unravel the secrets held within these records and use this knowledge to shape a brighter future for Maji Ndogo. Best regards, Aziza Nanedi. So, this one is addressing the team which you are part of, that they have 60,000 records. In the one that we just downloaded, the zip file, there are 60,000 records, and so they are telling you to learn the data, know or make sense out of the data that you have before you, and that is all that we are going to do. So you see that on the sidebar we have one, two, three, four, five, and they are all in red. The blue one is the one I'm currently on. That is the introduction. So when you see that this one is blue, it means we are currently on this. So you go, we'll look at get to know our data, dive into sources, unpack the visit, water source quality, and pollution issues. So they are all here. So let's move on. And then Chidi Kunto is also saying, "Hey team." So Chidi is also part of the team. Hope this message finds you well. I'm Chidi Kunto, and I'm really excited to be working with all of you on this upcoming project. Our president, Aziz Naledi, has given us a monumental task. We've got this mountain of data, and it's our job to sift through it, finding those nuggets of insight that will help us solve our water crisis here. So, Chidi is also talking about we going through the data and making sure that we understand the data. But you won't be doing this alone. As your mentor, I'll be here not just to guide you, but also to show you firsthand how a real data project kicks off. I'll be taking Naledi's instructions and breaking them down into clear, manageable tasks. And of course, I'll be sharing a few valuable tricks of the trade along the way. I'll help you navigate through this data landscape, turning those raw numbers into meaningful insight. Just remember, every data point can be part of our solution, and every step you take in this project helps us get closer to our goal. So that is it. So Chidi is basically going to help us through the whole process. When the instructions are given, he is going to break it down for us to also go through it. I am looking forward to working closely with each of you, learning about your unique perspectives and figuring out how we can best collaborate as a team. With your skills and dedication, I am confident we can unlock the potential of this data and make a real difference to the people of Maji Ndogo. Please know that my virtual door is always open. If you need some guidance, want to clarify something, or just have something cool to share, feel free to reach out. Here's, here's to an exciting journey ahead and the valuable lessons we will learn together. Cheers, Chidi. So that is what is going to happen. We are going to learn about the data. But one thing you should know is that this thing that we are reading is not actually telling you to do, should I say, it's not actually telling you to do the project and use the project to answer MCQs. That is what you should bear in mind. This is not actually telling you to do the project and use the project to do MCQs. I think that is my personal opinion, because as I went through the whole thing, I realized that I went through the first part of the project. I realized that we are just practicing using this. We will practice what we've learned, the select statement, the from, the create table, create whatever, all those things. We are just going to practice them here. But the MCQs are asking you things which will be based on the same data though, but it is not going to be based on what you did here in these instructions. Um, it is going to be based on how you understand the data. So they are going to ask you certain things, and then you are going to enter the query, and then get the answer from the query, and then just select the correct answer. Some of them too, they will give you the query and ask you the results. So it is a way of testing you how you understand the queries, or how you can query some data. I think that is it. So you make sure that you go through this with me. You may think it is not necessary, but it is very necessary for you to understand this. When you understand this, you'll be able to do the MCQs. So the Chidi from Chidi says, "Hey there, you've probably seen President Naledi's message by now. She has emphasized the importance of our newly collected survey data and how vital it is for us to dive and start making sense of it. As a senior data analyst, I've taken a close look at her message and have broken it down into a series of tasks that we need to tackle. So let's roll up our sleeves and get started." So Chidi has broken everything into series of tasks, and these are the tasks: the first, the second, the third, the fourth, and the fifth. So get to know your data. Before we do anything else, let's take a good look at our data. We will load up the database and pull up the first few records from each table. It's like getting to know a new city. We need to explore the lay of the land, and before we can start our journey. So first of all, we have to get to know our data. So we have to open our SQL bench. I already have the data here, but I'll drop it. I'll drop the database first, so that I'll do from scratch, then you follow along. So I'm dropping my database, and this is the query: drop database, and then my database name is what? MD Water Services. So after that, I run this. So I drop the database. So I have nothing on this panel, or where the schemas are. Then I close every window I opened here, or every tab. So don't save this. Don't save. Don't save. Good. So if you open your workbench and there's nothing there, this is how the thing will look like. So after we have extracted our additional download here, we have this folder. So this is the folder we want to open. So let's go to my SQL bench. Then this one here, we click on it. Then we go to where we downloaded the additional, and it is here. So I can find mine here. You double click on it, and then you select the MD Water Services. Then you click on open. Now it is not immediately a table that when you open it will just come. So when you refresh here, there's nothing happening. So these are SQL commands that will give you the data. So what we are going to do is that what we are going to do is that we are going to run these commands. So my cursor is blinking inside the command, and then I click on run here. Don't delete anything before you run. As it is, then click on run. Okay, so you wait for some time. I think it's still loading. Good. So it has finished loading because I can see a notification down here that at 11:24, and that is my time currently, there has been some changes or some changes here. So I'll come and refresh this, and I can see my MD water services created. That database has been created. So I can expand the tables, and you see that everything is here. And our instruction is saying that we should know our data. We should know the number of tables. We should know all these things. So that is what we are doing. It says we'll load up the database and pull up. So let's wait. There's further instructions on this. Then we should also dive into the water sources. Um, we've got a whole table dedicated to the types of water sources in our database. So let's dig into it and figure out all the needs. So these are the points given. Unpack the visit to water sources. And then we also have assess the quality of water sources and then investigate any pollution issues. So by working through these tasks, we will not only be answering President Naledi's call to explore the database and extract meaningful insight, but we'll also be honing our SQL skills. So look at this. By working through these tasks, we will not only be answering President Naledi's call to explore the database. So President Naledi was calling on us to what? Explore the database and extract meaningful insight. But we will also do what? Improve on our SQL skills. So that is basically what this whole thing is about. Okay, so you should know that. So now let's start what we just started. So start by retrieving the first few records from each table. How many tables are there in our database? So from here, this question, uh, I can close this one. So how many tables do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 tables. So if it is a question, we have already answered that. So we now know the number of tables. We have 8 tables. What are the names of these tables? And we know these tables, their names. We have data dictionary, employee, global water access, location, visit, water quality, water source, well pollution. So they are all the table names. Once you have identified the tables, write a select statement to retrieve the first 5 records from each table. As you look at the data, take note of the columns and their respective data types in each table. What information does each table contain? So I don't think they showed you this at whatever. So this one, I don't need to read it. Let's get to work. So I will click on this because I don't have anything here to write the commands. I'll click on this, the first one, SQL. So I click on it so that this thing will appear. Now look at this. You see the top here, we have limit to 1,000 rows. It means when we do select statement, it will give us the first 1,000 rows. If the rows are less than 1,000, no problem. But if they are more than 1,000, it will give us only the first 1,000. But remember that when I was reading from President Naledi's statement, they said we have 60,000 what records. So it means in this case, when we are searching, we select, we will get only 1,000 rows instead of what? The 60,000. Okay, so is it 60,000 or 6,000? I missed that. Yeah, 60,000 records. So I think that is it. So at that point, we can click on this arrow and you see that we have 50,000 rows here. We can, I think we can click on this. I don't know if it can be more. Let me see. I think that is the maximum we can go for now. I think that is the maximum we can go for now. So let's do it that one so that we can be able to get all the data that we want, almost all. They said we should explore the tables. So when I click on this, I can decide to click on this and then the formula will come. Select. So the select statement and then the star means select all from MD Water Services dot employee. So MD Water Service, that is the database, and then the employee is the table name. Now, when I remove this and I just do from employee, when I run it, it is working. Sometimes it doesn't work. I don't know why today it is working. But sometimes when you run just this, it doesn't work. Let me try well pollution and see. Okay, so it's still working. But sometimes when you try and then it's not working, it means that it is not recognizing this database. Especially, it could be that we have two databases or two or more databases, so it doesn't know which one has this table. So that is why we have this at the beginning dots. So we have MD Water Services dot employee. And if you still want to use employee alone or whatever, you first use the database. So you use, that is what you were taught. So use, then type in MD Water Services. So when you type this and you press run, sorry, good. So now that we are using, you see that this one is what? Boldened. So it means that this is the active database. So I can decide not to bring the dots and everything will still be working fine. Okay. So they said we should explore the data, the tables. Now this table has some columns. Um, Let me come here. So let me come here and expand this a little. So you can see that, okay. Um, okay, so we see the columns like this, but if you want to see the data type, we just click on them here. And you can see their data types here. So we are talking about the employee. You see, we have assigned employee ID, employee name, phone number, email address, province. They are all here in this table. Town name, position. They are in this table. And it returned 56 rows. So this one has 56 rows. And the first column is an int. The data type is what? An int, and it is a primary key, PK. And then the employee name is a varchar with 255 characters. The phone number is also a varchar, so this is not int. The phone number is not int. And phone number cannot be int mode, but the phone number is a varchar. Email is also a varchar. Address, so the rest they are all varchar. So when we come to this one, let me click on this global water services. Wait, sorry. So MD Global Water Services, MD Water Services dot Global Water Services, and that returned 464 rows. So that one too, we have the name, which is a string or a varchar. The region is a varchar, and then the year is an int. The year is an int. Then we have pop n is a float. Okay, pop n is a float. Then the rest are all here. So you can see all of them here. You can go through them yourself. Yeah, like that. So this one is not difficult. You just use select all, that is star, from, then the table name. Okay. So they said we should do what? We should use the select statement to fetch the first information. So these are the names of the tables, and they showed it here. Yeah. So that is it. And then it looks like someone took the time to name all of these tables pretty well, because we can kind of figure out what each table is about without really having to think too hard. Water source probably logs information about each source, like where it is, what type of water it is, and so on. So let's have a look at one of these tables. Let's use location so we can use that killer query, select star, but remember to limit it and tell it. So we are going to location table. So I think it's already here. Let me delete this so that it will look simple. So select star from location. Good. So sorry. Good. So I selected star from location. You see, it returned about 39,000 plus. So they said we should limit it. So let's limit it to 10 rows. So I write limit 10, then we run it. So that is 10 rows returned here. You can see 10 rows. So these are the things you see here. And that is what he also has here. So he limited it to 5 rows. We limited it to 10. No problem. So we can see that this table has information on a specific location with an address, the province and town and location is in. And if it's in a city or not, we can't really see what location this is, but we can see some sort of identifying number of that location. So they are trying to let you understand the table that this is a location ID identifying the location. So this is an address for the location, the province, and then the town, and the location type, whether it is an urban or not. So these are all here. Okay. Now let's look at the visit table. So let's look at the visit table. So where is the visit table? Let's open that. Now this is the visit table. It is returning a maximum of 50,000 rows. It means it is more than that. Now the visit table has a record ID, it has a location ID and a source ID. You see that the location ID, we can find location ID in this, in the location. So it means that in the visits, people visited a particular place, which is the location, and then the source of the water, and then the time it was recorded, and then the number of visits, then the time spent in the queue, and then the ID for the assigned employee. So you can see this table contains that information. So it means that this location ID is linked to this location ID. So they are similar. You see that there's an ID here. It says AKHA, then I think 5 zeros. When you come here, it's the same thing here. So it means that when you come to the visits, the AKH, whatever location is what? To Addis Ababa Road. So it means this employee 28 with the ID 828 visited to Addis Ababa Road. Okay, to Addis Ababa Road. This is it. Visited to Addis Ababa Road, which has this source, this water, whether it is a tap water or whatever, well or whatever. So this one too is linked to the water table or the water source table. Okay, so when you go to the water source table, let me open that one too. Good. So we have the water. So we have the tap in home, well, tap in home broken. So when you come to the visit table, is it a tap in broken home in 2 Addis Ababa Road? That is the address. And do you have, is it a tap in home location or it is a well water? And the time spent in the queue, this one didn't spend any time. I think they went and then just started uh, using it or something. So the time of record is this time, and then the visit is only once. Good. So I think I've explained something that they will later explain here. So yes, so this is a list of location ID. So this is the visit table, the one I just showed you. So this is a list of location ID, source ID, record ID, and a date and time. So it makes sense that someone assigned employee ID visited some location, and that is this location. In our case, we had a 2 Addis Ababa Road as one example of the locations at some time, and this is the time of record, and found a source and found the source, whether it is a tap water or whatever. Often the ID columns are related to what another table. As I said, the location ID is related to the location ID in the location table. Are related to another table. So in this case, the source ID in the visit table refers to source ID in the water source table. So the source ID in the visit table, and this is the visit table. This is the visit table is related to the source ID in the water source. So this is a source ID here. There's a source ID here, which is this source, and then there's another source ID. So you see, we are lucky that this source ID matches with this first one. So tap in home. So it means that this person visited to Addis Ababa Road, where the tap in home, where the source is what? Tap in home. Yeah, tap in home. And then the number of visits was what? Once. And then they didn't, so tap water in your house, you don't queue for it. So you see, so that is it. That is why we have zero. So you see, we are now understanding the data small, small. Let me move on. So they are saying that the source ID in the visit table refers to the source ID in the water source table. This is what we call a foreign key. So the source ID here is what we are calling a foreign key. And then the source ID here in the visit table is the foreign key, and the source ID here will be the primary key. So that is in the water source. So you see the water source, look at it there, this one. You see that is PK. Now when you come to the visit table, the source ID here, you see that they didn't indicate that it is PA, primary key. So it is linked to something somewhere. Okay, it is linked to something somewhere, and that is what they are saying, that it is a foreign key. Okay. Okay, so let's look at the water source table to see what source is. Normally, ID columns are related, so they came to the water source to see exactly what the source is, and I've explained that one to you already. Nice. Okay, we are getting somewhere now. Water sources are where people get their water from. Okay, this database is actually complex, so maybe a good idea for you is to look at the rest of the tables quickly. You can just select them, but remember in good SQL, there will be a data dictionary somewhere that documents all of this information. So you should read that as well, and even keep a copy of that close. So the one that they gave us, that is the data dictionary. When I open it, look at what is here. So we have employee with the column name. So with the column names here, and then they have the descriptions. So if you don't understand any of them, you come here and then you read about them with their descriptions. So the column name and then what it means. Okay. So a data dictionary has been embedded into the database. If you query the data dictionary table, an explanation of each column is given there. So you can query for those ones. Uh, Now let's move to the second one. You see that on the sidebar, you can see that this is now green. We are done with the first one. We are now in the active, the blue one. Every time this one is blue, then that is the active lesson you are on. Now that you are familiar with the structure of the tables, so it means that we should be familiar with the structure of the tables. You should know that this is employee table and we open it already. So here is it. Employee, we have assigned employee ID. You see that we have employees here, employee ID here with employee name. And you remember we had visits where we also had employee ID. Look at this. So we have employee ID here. Let me see. So this is employee 48. When we come to, I'm not using query to look for them. I'm just trying to get them from the table straight. So 48. When I come here, 48. Who is that? Yewande Ebele. Yewande Ebele. This person has a phone number, doesn't have an email. The person has an address, a province name. So this person, Yewande Ebele, visited this location, this place, and this location, when you want to know the exact location, you come to the location table and look for this particular ID and then get the real name for this location. And then the source water, you should also. So this person visited this location of this particular source of water. And then the number of the time spent in queue was zero. The number of visits is only once. This same person visited this location. So this person has visited several locations. You see that? So you see that? You see? So the employee has visited a lot of locations and recorded them. You get it? So that is exactly what is happening. So you see that the tables are related in a way where the location is related to the visits, and then visit is related to, I think, the water source. And then we have also water quality here. Let me open that. So the water quality, we have visit counts, and then subject quality score, where we will talk about this later. Then we have water pollution too. We have its source ID. See that source ID appears here again. So this is the source, water source, and the date and the description, the pollutants and other information. All right. So let's continue from here. So now it says, now that you are familiar with the structure of the tables, let's dive deeper. We need to understand the types of water sources we are dealing with. Can you figure out which table contains this information? Once you have identified the right table, write SQL query to find all the unique types of water sources. So we want to get all the water sources here. So let's go to our table. Let me come back here. I don't want to close these tables that I have opened. Let me close this particular one so that it will be left with this one. Okay. Then let me add this SQL. Come and put it here. Good. Now I want to open the water source. So to open the water source, you go select star from. So from then water source. So this is it. But it said we should only get the unique ones. So we will not select all of them. We will select only this column. So we'll do type of water source. So this is the column name, type of water source. And what we get is only this. But we still have tap in home broken, tap in home broken. We want only the unique names. So we will do select distinct. So select distinct. Then we run. So you see that we have distinct. So tap in home, we have only 5 types of water source. Tap in home broken, well, shared tap, and river. Okay, so I think that is what we have here. Let me quickly bring you up to speed on these water source types. So we have the river, and they are saying that people collect drinking water along a river. This is an open water source that millions of people use in Maji, Ndogo. Water from a river has a high risk of being contaminated with biological and other pollutants. So it is the worst source of water possible. So in the water sources, this is the worst source of water. That is the river. So they gave us an example of where a river is their source of water. Then we have well. These sources draw water from underground sources and are commonly shared by communities. Since these are closed water sources, contamination is much less likely compared to river. So well water is better or as compared to river. So unfortunately, due to the aging infrastructure and the corruption of officials in the past, many of our wells are not clean. So this is an example of that. And then we have the shared tap. This is a tap in a public area. So tap water in communities where people share. That one too is there. And then we have tap in home. These are taps that are inside our homes. On average, about 6 people live together in Maji, Ndogo. So each of these taps serves about 6 people. So in every home, six people use a tap water. So broken tap in home. These are taps that have been installed in citizens' home, but the infrastructure connected to that tap is not functional. This can be due to burst pipes, broken ponds, or water treatment plants that are not working. So we will have taps where some of the pipes or whatever are broken, and so those things, those ones too are there. So they recorded for all these sources of water. Now, an important note on the home taps. So the home taps, you remember they said six people live together in Maji for the home taps. Now they are saying that there's an important note on that. About 6 to 10 million people have running water installed in their homes in Maji, Ndogo, including broken taps. If we were to document this, we would have a row of water for each home. So it means that if we were to document that each home, like we have 6 million people that have taps installed in their homes. If you have to document this, it means you have a lot of rows. So one record is to one tap. Okay, that means our database would contain about a million rows of data. Okay, which may slow our systems down. For now, the surveyors combine the data many households together into a single record. So, for example, the first record, this one, is for tapping home. I think we talked about this ID. So, tapping home, that says 956 people. What this means is that the records of about 160 homes here nearby were combined into one record. So it means that 956 people, they are from, uh, should I say, uh, they are the total number of people from the various homes. Okay, but then if we are to divide them into homes, which on average each home is supposed to have six people, so it means that when we divide this by six, we are going to get 160 people. Okay, then that is why they've written 160 times what, six. So when we divide the number of people by six, which it means that this 956 is for all the people put together for six, for a record. Okay, so in order for us to know the number of homes in this number of people, we have to divide by six, because on average we know that each home has to have what, six people. Okay, or each home uses each home with the tap water uses, or six people uses the tap water in the home, in the house. So that is what we have here. So one tap in a home, or tap in home broken record, actually refers to multiple households with the sum of the people living in these homes equal to number of people saved. So that is what is there. So we have, um, where is it? Okay. Water source. Yeah. So if we have this tap in home 956, it means that we have 160 homes being served. Okay. Mhm. Then we have tap in broken home. So the ones with the tap in home, whether in broken home or in whatever. So that is it. So we have tap in home 956, and then tap in home broken 930. So this 930 divided by 6 will give you the number of homes. Uh-huh. So that is it. So the third one says unpack the visits to water sources. We have we have a table in our database that logs the visits made to different water sources. Can you identify this table? So the table that logs the visits. That is the visit table. Write an SQL query that retrieves all records from this table where the time in queue is more than some crazy time, say 500 minutes. How would it feel to queue 8 hours for water? So when we come to the visit table, you see that we have time in queue. Some are 0, some 16. Now we want to see if some people queued about 8 hours. So they are saying let's use 500 minutes. 500 minutes should be, yeah. So 500 minutes should be somewhere around, when we divide by 60, we are going to get 8, around 8 hours. So select from visits. So we have that. Where, so we use our where statement, where time in queue, in queue, sorry, in queue is, let's say greater than 500. So we are looking at the one that the time in queue is around 8 hours. So let's go. Now you see, so this water source, when the employee went there, or the time in queue recorded was what? Over 8 hours. So these ones are over 8 hours. See, so you see, over 8 hours. Okay, over 8 hours. And they are asking, how would you feel to queue for 8 hours for water? So it means that in actual fact, this ones that they are queuing more than 8 hours and all that, they can't be tapping hose. They can't. It's either they are shared tap, or they are well water, or they are rivers or something. I don't know. Rivers, I don't know whether they will queue, but I think they will be shared water or well or something. So because that is where people use, it's a public, it's for the public. So it's likely people queue for that. And so look at the time that they used to queue for such water. So that is what they are asking. And then they had the table like ours, similar to ours. So whatever I'm doing, you also do. You try to type the code, then you will get meaning out of it. If you want a particular column, you just replace the star with the column name for that particular table. Okay. Um, Now it says, how is this possible that we can what? Queue for what? 8 hours. So I am wondering what type of water source take this long to queue for. You will have to find that information in another table that lists the types of water sources. So you see, when you have the source ID here, you can go to the other table and trace these source IDs to the names of the water sources. If I remember correctly, the table has type of water source and source ID column. So let's write down a couple of these sources ID values from our results and search for them in the table. So they wrote down some IDs and then search them. So look at this. These are the IDs they wrote, and then they intentionally chose some IDs that the time spent, or the time spent in a queue is 0. Okay, uh, so that is it. So these ones are the ones that the time spent in a queue was crazy, like 500 minutes, and these ones are the, so they want to see the water source that gives us those huge minutes, and then the ones that gives us the 0 minutes. So let's try to write uh, something for that. So that is the water source. So we will use water source. So water source where time uh, where source ID is equal to. So let me pick from here. Uh, where source ID is this. So let me do this. Oh, sorry. Let me do this. Or 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 this or that. So we are trying to get this done. Okay, good. So when we search for this, look at them. They are all shared water tap. They are shared tap. You see, these are the ones that were 500 plus. So they said, I am wondering what type of water source take long. You will have to find that information. So let's write down a couple of these source ID values from our results. And they were the ones they wrote from here. So they wrote, I think, this one, and then this one also. So they were all 500 plus time in queue. And we realized that they are all shared tap, shared tap, shared tap. You get it? So now let's try the ones with the 0 minute. So I'll select this. So the zero, when you check the water source, I think the visits, um, not this one. Okay, I wanted to open the visits. So okay, so you let me put this one here. Um, and then this one here. Then let me remove this one so that we can see these ones to see. Now look at this. This is tap in home and this is well. Okay, so tap in home and this is well. So tap in home actually or definitely it is your own tap. So if you have 6 people using a tap in your house, it's not likely you will queue for long. You will not even queue. It's not likely you'll queue. And then the well too, it could be for an individual or 6 people as usual. But at the end of the day, they didn't queue. These people didn't queue. Okay. So we now know what is going on. So you see, so they also try to check it. So they checked all of them at a go, and they found out some of the tap in home and all that. All right. So I added a couple of others. So they added some others. No problem. Sorry, well, if you check them, you see which sources have people queuing. The field surveyors also let us know that they measured sources that had queues a few times to see if the queue time changed. So the survey also uh, measured sources that had queues a few times to see if the queue time also what changed. So some of them they checked if the queue times also changed. Now the visits, I think when I go to the visits, let me delete this. and go to the visits. Visits. Good. We have the queue time here. Then we have the source ID. Okay. Now we can look for some of the source IDs to see if the queue times have been changing, because the source ID, some of them will look the same. So let me see if I can get some source IDs where they will there will be few of them listed so that we can compare it. Let me see if it will work. Okay, this source ID is only one. Let me get another one. Good. So this one has a source ID of the CC. So this employee went this place at this date, 1st January 2021, 2nd January, 3rd, 4th. So all these times they are different. So time in queue for the first one was 240 minutes, 248, 104. So it is not constant with this particular source. Uh, so that is exactly what they said here. The field surveyors also let us know that they measure sources that had queues a few times to see if the queue time changed. So they had queues a few times to see whether they changed. And truly, some of them they changed. The quality of our water sources is the whole point of the survey. So we are now on the water quality. We have a table that contains quality score for each visit made about a water source that was assigned by the field surveyor. They assigned a score to each source from 1 being terrible to 10 for a good clean water source in home. Shared tasks are not rated as high, and the score also depends on how long the queue times are. So we have this one, I think the water quality. And so 1 means terrible and 10 means it is good. So from 1 to 10, you see 5 means average, 4 is not so average, it is like it is getting bad, and then 0 means it is worse. So I think that is the quality score we have here. Um, so it says, let's check if this is true. The surveyors only made multiple visits to shared tabs and did not revisit other types of water sources. Okay, so the surveyors only made multiple visits to shared tabs. So only shared tabs that the surveyors visited multiple times. The other types of sources they didn't revisit. So there should be no records of second visit to locations where there are good water sources, like taps in homes. So those places they didn't revisit. So please write a query to find records where the subject quality score is 10 and where the source was visited a second time. So we are going to write a query where the subject quality score is 10, only looking for what? Home tabs. And where, so because it is of quality, they are home tabs. And where the source was visited a second time. So if the quality is 10 and then the source is this visited the place a second time, then there's a problem. because we are thinking they will not visit the place again because it is of uh, high quality. So let's do that and see if you get 218 rows. So we go to visits where subjects subjective quality score is 10, and so we use the and, sorry, it's 10 not 20, and visit count is 2. So that is what we are looking for. We want the one with the subjective quality score. Um, subjective quality score. I spelled something wrongly. Um, where sorry. Okay, so this is it. So we'll have subjective quality score to be 10, and then the visit count is 2. Okay, so we do that when the quality is 10, then there's no need to visit the place again and do the recording. Um, so it says we should look through the table, and then uh, let's check if this is true. So this is what we got, the 18 rows, but this should not be happening. I think some of our employees may have made mistakes. To be honest, I'll be surprised if there are no errors in our data at this scale. I'm going to send Press Naledi a message that we have to recheck some of these sources. We can appoint an auditor to check some of the data independently and make sure we have the right information. So we know that that is an issue there. Then the fifth one says we should investigate pollution issues. Did you notice that we recorded contamination pollution data for all the well sources? Find the right table and print the first few rows. So we go to the pollution, the well pollution. Um, so that is well well pollution. Okay, well pollution. Good. So this is well pollution. So we select star from well pollution and then we run. And then this is what we get. They said we should limit, or they, even if they don't, or they didn't, we should limit it to, let's say, 10. Okay, so let's look at what was said. Uh, so this is what is it like? This is how it looks like. It looks like our scientists diligently recorded the water quality of all the wells. Some are contaminated with biological contaminants, while others are polluted with an excess of heavy metals and other pollutants. Based on the results, each well was classified as clean, contaminated, biological, so contaminated biological or contaminated chemical. It is important to know this because wells that are polluted with bio or other contaminants are not safe to drink. It looks like they recorded the source ID of each test. So we can link it to the source at some place in. So you see that there's a source ID for the water, whether it is a tap water or it is what's the name? Whichever water source it is tap, well, or whatever, so that we know that it is contaminated or it is not. So we have the results here. We have the clean, contaminated, biological, contaminated, chemical. They are all there. So let's move on. In the well pollution table, the descriptions are notes taken by our scientists as text. So it will be challenging to process it. The biological column is in unit of CFU per ml. So it measures how much contamination is in the water. Zero is clean. Zero is clean. That is this column, the biological column. Zero is clean, and anything more than 0.01 is contaminated. Let's check the integrity of the data. The worst case is if we have contamination, but we think we don't. People can get sick, so we need to make sure there are no errors. So you see, we know that if it is zero, it is what? Clean. If it is not zero or it is greater than 0.01, it is not clean. So it could be that we have something more than zero and if written clean. So that is what they are trying to say. So write a query that checks if the result is clean, but the biological column is what? Greater than. So if the biological column is greater than a 0.01 and it is clean, then there's a problem. So let's go and try that. So we select from well pollution where okay, so I want you to see this clearly. Okay, where biological is greater than 0.01 and we use the end results is equal to clean. So we don't want to see clean and then that this thing is greater than. So it means if it is greater than 0.01, it is not clean, but it could be that they've written clean. So let's try it and see. So you see, we have these ones with the biological being greater than 0.01, but yet they've written what? Clean in front of them. So that is it. So we don't want this situation where this is written clean when actually it is not clean for usage or clean for drinking. So that is exactly what they got here. If you compare the result of this query to the entire table, it seems like we have some inconsistencies in how the well statuses are recorded. Specifically, it seems that some data input personnel might have mistaken the description field for determining the cleanliness of the water. It seems like in some cases, if the description field begins with the word clean, the results have been classified as clean in the results column, even though the biological column is what greater than 0.01. When we work with real world data, we may find inconsistency due to data being misinterpreted based on a description rather than its actual values. Let's dive deeper into the cause of the issue with the biological contamination data. So VSL has told me that the description should only have the word clean if there is no biological contamination and no chemical pollutant. So the description here should be clean if it is clean, but you can't have clean and bacteria, whatever. So that is exactly what they are saying. So because they were confusing this with that, so they see clean ahead and then they use clean here. So that is what we are seeing. So some data personnel must have copied the data from the scientist note into our database incorrectly. We need to find and remove the clean parts from all the descriptions that do have a biological contamination. So this mistake is not made again. So all the descriptions that do have biological contamination, they also have that clean biological contamination. These ones. We also have all of them. So you can see those ones, they all have contaminations. The second issue has arisen from this error, but it is much more problematic. Some of the field surveyors have marked wells as clean in the results column because the description had the word clean in it, even though they have a biological contamination. So we need to find all the results that have a value greater than 0.01 in the biological column and have been set to clean in the result column. So they are looking at this one to some of them they have clean in front and clean here. You see? So this one doesn't have clean, but then the biological column is greater than 0.01 and they said it's clean. So that is the problem we have now. Okay, first let's look at the descriptions. We need to identify the records that mistakenly have the word clean in the description. However, it is important to remember that not all of our field surveyors use the description to set the results. Some check the actual data. So it's not all that they just looked at this and then said it's clean. No, some actually looked at the data to set the results. The query should return 38 wrong descriptions. So let me see which query they are talking about. To find these descriptions, search, so that is the descriptions with the clean in front. Search for the word clean with the additional characters after it. As this is what separates incorrect description from the records that should have clean. So we have to modify this. So where the description like, so we use the like keyword, and then the clean, so clean is in front. You know that clean starts this, but then if we close this, when we do this, it will show the ones with clean, and these ones are actually clean. You see, so you see all of this, they are actually clean because this one is not greater than 0.01. Okay, so these ones are actually clean. So if you search it like this, you get it wrong. We want the one that came in the beginning that clean, and then there are some characters in front. So we put, at least it should have a character in front, and then any other characters. So the percentage means one or more character, zero or more characters, and then this dash means at least one character. So clean, then if there's a space in front, cry, it will bring that clean. So that is exactly what is happening here. So when I click on it, now it says 38 rows returned. You see, so the 38 rows returned is what they said here. So you know that you are on track. The query should return 38 rows, wrong descriptions. Now we need to fix these descriptions so that we don't encounter this issue again in the future. So looking at the result, we can see two different descriptions that we need to fix. So looking at the result, we need to fix clean this one. When we look at the results, we have this, the clean bacteria colon Giardia lamblia, and then the other one, clean bacteria E. coli. So they are the ones we are looking at. So we have to, it says we should do what? We should change this, should be updated to what? Bacteria E. coli instead of clean at the beginning because it is not a clean water. We can't put clean there. The second issue we need to fix is in our result column. We need to update the result column from clean to contaminated. So where they have written clean bacteria, you see that the result column has clean. Meanwhile, this thing is not clean because the biological this thing shows that it is more than 0. So this is not clean. So it means we have to write biological whatever where it is clean. Okay, so we need to update the result column to contaminated biological, where the biological column has a value greater than what? 0.01. So we use that condition to get it done. So here are the steps. Okay, so here is how I did it. So this is the how Chidi did it. Case 1A, update descriptions that mistakenly mention clean bacteria this. So we have to update that. And then we also have to update the description that mistakenly mention whatever, the clean bacteria, whatever. So before we make these changes, here is another nugget of advice. Begin complex queries by commenting on what you will do. This helps us to think through the problem before we write code to solve it. And once we are done, we have a well documented code. So this is it. So we use updates and then we update the well pollution table. Then we set then where. So it came to a point where we cannot. So this is the actual formula. Okay. So we update the well pollution, set the description to this where we have the clean, and then so it will do that. So it says we should go ahead and fill the rest. Now, when we change any data on the database, we need to be sure there are no errors, as this could fill the database with incorrect values. A safer way to do the update is by testing the changes on a copy of the table first. So we can't go and change it directly because if we do a mistake, it is going to replace the values with the wrong data. So we create a table as. So we do as, then the query, this query. So as this query, then we put this query there. So sorry, we put the query to select that particular table that we want to change. So create table new as, select all from that table. So this is it. So let's do that so that we will not find ourselves wanting. So that is in the pollution table. Select from the pollution table. So we do create table. So let's do well pollution copy as, then I put it in brackets. Oh. So when I run this, it is going to create a copy for me. So when I refresh here, I'll see that copy. So now, whatever I have to do, instead of using well pollution copy, I'll use instead of using well pollution, I'll use well pollution copy. So if I do this from well pollution copy, so this will give me this, and I can still continue with what I was doing, where biological is greater than 0.01 and results is equal to, our result is equal to clean. I think this was what we were doing in the beginning. Okay, so you see that we still have the same data, and then we did this where description like, then we had clean, and then this. Okay, so we had the character and then this. So that one too, 38 rows. So you see that it is the same data that we are using, just that we had a copy. So that we can do the correction on this copy, and if it is successful, we can use the code on the original copy, then delete this table. Okay, so we have created it successfully. So now we can do this. We can run this copy. So it says that we should update. Look at this. It says update. So let me comment this out. It says update, update. Well, pollution copy. Then set. Set description. So we should set the description to bacteria colon E dot coli. So this is it, where description is the negative, where the description is almost like the, but then it has clean at the beginning. So we do that for the other one, and then we also so we do that for the other one. So I'll copy and paste it here. Update Giardia, is it Giardia lamblia? to the same thing here. Okay, so I have this here. Sorry. So the first one I didn't terminate. So here I terminate this one. I am done with this one too. Then I'll do the last update that says update well well pollution copy set results equals where the result is what conta where we will put contaminated colon biological biological. Okay, so where we put contaminated biological, we'll, we'll put contaminated biological where biological is greater than 0.01 and our result is clean. So where the result is equal to clean. So that is what we are doing. Good. So this is basically what we are doing. We are let me bring this one down. So we are updating the well pollution table where it has clean bacteria equally like what we have here. Wherever it has this uh, the equally or whatever, this one, and replace it with bacteria equally. We don't want the clean to be there because it is not clean because this one is bigger than 0.01. We do the same thing for the other one. So this one with clean bacteria Gardia lamblia, that one too we change it to bacteria Gardia lamblia. And then the result column, when it is this thing is greater than 0.01, don't write clean, but write what? Contaminated biological. Exactly what we are doing. So let's run this. Um, so they said we are using safe mode. So let's. They said when it is safe mode, we should change it. We should remove. Um, you should write a code at the top. That is set. So set SQL safe updates equals 0. So we do that, then we run it. It's still giving me that. Okay, sorry, I didn't terminate it. So that is it. So we had 64 rows affected. So it has done the corrections for us. So now let's comment this one out. So I'll comment all of them out and then run this again to see if really those things have been removed. So when I search, you see it's not coming again. I'm not seeing a result where clean is in front like that and then whatever is like that. So it means it has been resolved. And then we can also look at where the results are bigger than. So biological, where biological is greater than 0.01 and results equals clean, to see if we will find a result. If we don't find a result, it means it has been replaced. So we don't find anything. So it means we don't have biological which is greater than 0.01 and it has been labeled clean. Anything greater than 0.01 is labeled biological, as we did here, contaminated biological. All right. So I think that is that for this particular. So it says we should put to test. So we have done that, and then these are the code for the testing. So I think that is all basically. So if we are to run this on the original copy, um, then we are going to use, instead of well pollution copy, we remove the copy in front, then we uncomment this and we run it, then it will take effect on uh, well pollution, this one. Okay. So I think that is it. So you can do that and then see. And then you remember that we also had something like um, okay. So I think we have corrected everything. Yeah, I think that is it. So I thought I haven't done some corrections, but I think we have done everything. All right, so thank you very much for your attention. If you have any other problem, you can DM me or you can ask any of the members who understand the whole thing. And if I made any mistake anywhere, you can point me. I'm also a learner like you. I'm also learning small, small. So if you find any mistake I did or anything that I was supposed to do it in another way, you can also give me a suggestion or DM me so that I also learn from you. Thank you very much.